Friends, welcome to lecture number 5 of irrigation and drainage lecture series. So, in this we are going to solve some problems. Some of them may be the part of your GATE examination, and I consider this as a tutorial. Okay, so we are going to solve here the 6 problems. So, whatever theory we learned during this last week or this week. So, we are going to see solving some of the problems here. So, exercise 1, if you see, so this is a kind of a derivation. Okay, so, the first thing is, let us see, show that the water content, that is W, and specific gravity, that is G, and degree of saturation, that is SR, void ratio, that is E, are related as W G is equal to SR into E. So, this is the question. So, we have to show that W G is equal to SR into E. So, here the previously what we learned, we can get some feedback from those lectures. Like if you see the water content here, the water content is written as W, which is W W by W D. So, this is how do we get this W W by W D? Suppose if you remember the gravimetric method for doing the moisture measurement. So, suppose you have initial soil sample, which is a moist soil sample, right. Let us say that is a W 1. Then after that you kept this in an oven, right, and then you measured the weight after drying. So, that is W 2. Now, the moisture content, that is a capital W, which is equal to W 2 minus W 1 minus W 2, right. This is the moisture, right, present in the soil sample divided by W 2, the dry sample. So, the same thing here if you see. So, this is W W, right, and this is W D, this dry sample. So, that way we got this. Okay. So, then there is a void ratio. So, void ratio is volume of voids by volume of solids. Okay. So, this is known, and degree of saturation SR, that is the volume of voids by volume of water divided by volume of voids. So, that means you have like voids, right, you have voids, these are the voids and this is the soil. Okay, this is soil, and since this is a void, so some portion will be filled with water. Okay. And this is also water, this is also some portion will be water, and some portion will be void. So, this is the total void volume and volume of water. So, that is the degree of saturation. So, that means out of total voids, how much volume is occupied by water. So, that is that, and unit weight, which is gamma, that is weight by volume. Unit weight, all you can also call the density. So, the density is volume weight by volume, and specific gravity G. So, this is unit weight of the solid divided by unit weight of water, that is the specific gravity of water. So, with this information, so let us define gamma S, which is equal to, and from this you can get gamma S is equal to G into gamma rho. Okay. And W S by, so our aim is W G. So, our aim is W G is equal to S R into E, is not it. So, W you can put here W W like W D into G. G is rho S divided by rho W. Okay. So, and now let us I mean define rho s, W w by W d into, so rho s can be written in this term like density terms. Okay, so that is called W s into V s divided by W w into V w. Okay. So, I would put here without any confusion, let us put W s. Okay. So, then this will be W s, this will be W s. Okay. So, now, so here W w gets cancels out, V s gets cancels out. So, finally, you get V s by V w. Okay. So, then what we do, V s by V v divided by V w by V v. Okay. So, we divided both sides by V v. So, V s by V v, so V w by V v, so we need E s, right, W s by W b. Okay. Wait here R s is, or gamma s is, oh sorry. Okay. So, here let me see. So, W g, okay, so W z is equal to W w by W s, let us put s without any confusion, and g is s divided by R w, is not it. So, W w by W s into R s means W by V, right. So, I would put W s by V s, okay, and divided by R w, W w by R w, W w by V w. Okay. W by V w. Okay. So, now W w by V s W s into W s W w into, so V w by V s, okay, V w by V s. So, I will write down here V w by V s, okay, that which is equal to. So, now I am going to get these things cancels out, and finally, I got V w by V s. So, now as I mentioned before, so V w by V v and V s by V v. Okay. So, V w by V v, V w by V v, so this one. So, this gives S r, okay, and V s by V v, V s by V v. So, that is V s by V v, that means 1 by E, okay. So, which is equal to S r into E, right. So, in this way, so we started with W g and end with S r into E. Okay. Okay, so this is you can go through this. So, it is all procedure I mentioned, and then the second exercise. So, that show the relationship between unit weight, specific gravity, void ratio, degree of saturation, and unit weight of water. Okay. So, this is a big relationship. If you see this, the relationship looks like this. So, gamma is equal to G plus E into S r into R w by 1 plus E. Okay. So, here before that, as we did the previously. So, unit weight is W by V and void ratio V s by V v by V s, and degree of saturation V w by V v. Okay. So, let us start with gamma. So, the gamma is equal to V w by V. Okay. So, that can be written as, since this is a total weight. So, the weight of water and weight of solid, and this is the total volume and weight of volume of voids and volume of solids. Okay. So, then so what we do, W W can be written like this. Okay. So, how would we write? Because this is density, okay, this is the volume, density multiplied by volume you will get weight. Similarly, density multiplied by volume of solid you get weight of solids, and you keep the rest of the things. Now, gamma is equal to R W V W, and here so G has, where is G? So, look at this, R W V W plus so G is what is the specific gravity. Okay. So, the specific gravity G can be written as R S by R W, right. So, now R S is equal to G into R W. So, that is what you got here, right, G into R W for R S, and then V S similarly that, and then we next what we go to the next. So, here if you see, so this is from previous thing. So, V W plus G into V S. So, we took R W common both sides. So, then so S R. So, you know S R, degree of saturation, which is equal to V W by V V. Okay. So, then V W is equal to S R into V V. So, that is what here. Okay. So, V V is S R into V V, and G V S, and the rest of things are same. Okay. And gamma, now S R by, so just divide by V S on both sides, V V by V S, G into V S by V S, right, and also denominator V V by V S and V S by V S. So, the finally you get S R, and V V by V S is E, okay, and G, and this gets cancels out, and rho W divided by, and this will be 1 here, and V S by V S by V S. So, this is 1, and V V by V S is E. So, that way you get gamma equal to S R into E plus G into R W divided by 1 plus E. Okay. And this is third example, see, and third example, let us consider the tensiometer attached with a mercury manometer, you have seen that, and installed at 0.4 meter below the ground. So, this is the ground. Okay. So, the tensiometer is installed down. Okay. So, here is a bulb, ceramic cup. Okay. So, here this is a manometer which is installed. So, installed at how much? 0.4 meter, this one. Okay. Soil surface, height of mercury cup 0.2 meter from saturated soil. Okay. This is the mercury cup. So, height of mercury in the cup is 0.2 meter from here to here. Initially this is 0.2 meter for the saturated soil under saturation. The density of mercury is given. The rise of mercury in manometer is 0.6 atmosphere tension is. So, suppose if this is rising 0.6 meter atmosphere, or now what would be the rise of this water level, okay, when it is 0.6 rise of water level when it is a 0.6 atmosphere. Okay. So, when let us say psi m is equal to 0.6 atmosphere. Okay. So, what would be H? So, we know the formula is called P is equal or P by or H sorry, let us put this. Okay. So, we have like P is equal to rho G H. Okay. So, this is the formula where P is a pressure. Okay. So, pressure. So, that is in Newton per meter square, and rho, this is the density, is a kg per meter cube, and g acceleration due to gravity meter per second square, and h in meters. So, this is the formula we are going to use here. Okay. So, the tensiometer depth 0.4 meter, that is okay, we are not going to use that, and height of mercury in the cup 0.2 meter, okay, and density of mercury is given. So, density is given, G we know 9.81 and pressure 0.6, okay, this pressure 0.6. So, we are going so substituting this here, H is equal to P by rho G, okay, rho G. So, the P is 0.6, P is 0.6 atmospheres. So, atmosphere you have to convert this unit. Okay. So, 1 atmosphere which is equal to 1.013 into 10 power 5 10 power 5 Newton per meter square. Okay. Newton per meter square or 1 pascals. 1.013 10 power 5 pascals or Newton per meter square. So, this is given, I mean you can convert that, you can convert this by Newton per meter square, that is the unit, okay, that is the unit, and then density is given 13600, that is in kg per meter cube, it is already given, and 9.81, this is the meter per second square. So, I mean substituting everything, you get H into H is equal to, you get 0.456 meters. Okay. So, simply this exercise gives how to convert an atmospheric pressure into height of water column. Okay. So, the fourth problem here is you have a wheat field that needs to be irrigated with a depth of irrigation 50 centimeter. Okay. So, depth of irrigation, so the D which is given 50 centimeter, the duration of crop season is 125 days. Okay. So, let us say the duration which is 125 days. So, stream size 15 LPS. So, the Q which is equal to 15 LPS and following for 15 hours a day. So, the time is 15 hours per day, and irrigate an area. So, what could be the area? Okay. So, that is the problem. So, 15 hour per day, how many days? 125 days. If you can multiply these two, right, you get number of hours. Okay. Then multiply with Q, you get the volume, right, and volume divided by the depth of irrigation, you get the area. So, that is the same thing. So, depth of irrigation is 15 centimeter, duration of crop 125 days, 15 hours. Okay. So, the total for 15 hours 15 into 10 power minus 3 into 15, these are, so these are conversion 125 days and you converted. So, this is meter cube, right, this is in meter cube, and 15 days sorry 15 hours and 125 days. So, everything if you convert is you convert into volume. So, 101250 meter cube volume you get, and then area. So, this is the volume divided by the depth, right. So, depth you get, this is the area and this is in hectares. So, meter square, and if you can divide with 10,000 by 10,000, you get in hectares. Okay. So, then the next example. So, here the root zone depth of a crop is given 90 centimeter and its available water holding capacity is 15 centimeter per meter. Suppose this is a field, right. So, it has a root zone depth of 90 centimeter and you have 15 centimeter per meter, that is the water content, water holding capacity. Okay. And irrigation to be applied when 40% available water in the root zone is depleted. Okay. So, now what you have to find out, so what is the moisture holding capacity with 90 centimeter, for 1 meter 15 centimeter, for 90 centimeter how much. So, that is the number one step you have to do. So, with that, so that is your reservoir, that is your water reservoir. Now, you think about 40% of available water of this one, the water reservoir is depleted. Okay. And then if the daily water consumption, I mean withdrawal, so withdrawal from here is 3 mm per day, okay, from this reservoir 3 mm per day. So, then irrigation period is, so how many days you need to give irrigation. So, in other word, so how long it is going to take to remove 40% of this reservoir water at the rate of 3 mm per day. Okay. So, then simply you have to divide this 40% of the reservoir by 3 mm, you get in days. Okay. Here you see water holding capacity 15 centimeter per meter, root zone depth 90 centimeter, or that you convert into 0.9 meter. Okay. So, daily water consumption 3 mm. So, water depth 15 into, so this is what total root zone depth 15 into 0.9 meter. So, 13.5 centimeter of water which is available throughout the root zone depth 90 centimeter. So, this is your kind of a reservoir, okay, reservoir water, right. And then irrigation to be applied when 40% available water in the root zone is depleted. Okay. So, now get 40% of this and you get 5.4 centimeter, that is 40% of that. So, if 5.4 centimeter is depleted at the rate of 3 mm, so how long it is going to take? So, that is simple. So, for 54 mm you convert that, and irrigation period 54 mm divided by 3 mm, right, every day you get 3 mm is going to deplete. So, total it takes 18 days to deplete this 40% of total available water, right. So, this way you can calculate the irrigation, next irrigation basically. So, in the first, after 18 days you have to give next irrigation to replenish that 40% water. Okay. So, this is the last example of this tutorial. If you see this, so in this example a crop has effective root zone depth 1200 mm and monthly 30 days, as a monthly the crop evapotranspiration of 260 mm. Okay. The crop has effective root zone depth 1200 mm and monthly crop evapotranspiration 260 mm. The effective rainfall during 30 days period is 20 mm. The field capacity and permissible soil moisture depletion on volume basis are 16%, 8%. Okay. The irrigation interval in days for the crop will be. So, this similar kind of question, the previous fifth question. If you see this with this data, so data given is effective root zone depth 1200 mm, evapotranspiration 260 mm, 30 days period. Daily water consumption use 260 mm by 30 days, okay, because this is 30 days. So, daily you get 260 by 30 and effective rainfall 20 mm and then field capacity permissible were 16 and 8%. So, this field capacity per melting point. So, then so next what you have to do is here. So, net depth of irrigation. So, net depth of irrigation is theta f c minus theta w p wilting point divided by 100 into root zone depth, okay, R d, right. So, that will be 96 mm, that is the net depth of irrigation, and irrigation interval is equal to net depth of irrigation plus there is a rainfall, right. So, and then daily consumptive use. So, 96 plus 20 divided by daily consumptive use 260 by 30 days, right. So, 116 by 8.7 and finally, you get 13.37 or you can consider 13 days. So, in every 13 days you give irrigation, this is interval, irrigation interval. Okay. So, these tutorials will cover, covered already some part. So, that means solve physical properties and then the irrigation interval and other things. Okay. So, and thank you so much.